Right, okay, so last time we looked at Kruskal's algorithm for finding the minimum spanning tree of a network. Another one that does the same job is called Prim's algorithm. And Kruskal's, you keep looking at the whole network to keep choosing the shortest arc, such that it doesn't create a cycle. Whereas Prim's, you actually choose a starting point and your tree essentially grows from that point to span the network. So you always have one tree. Whereas with Kruskal's, you have random branches appearing throughout the algorithm until your tree is finished at the end. So I've written the algorithm down here. You select a starting node. It's arbitrarily, doesn't matter which one you start with. Okay, if it is an exam question, you're likely to be told which one to start at. The main step, connect the nearest node that's not already a part of your tree. So it's the nearest node to your tree that's not already a part of your tree. And then the third step is repeat step 2 until you finished. Okay. So again, we've got our kind of southwest regions. We've got Land's End, Truro, Bodmin, Plymouth, Oakhampton, Exeter, and Torbay. Any requests as to where to start? Yeah.
Land's End.
Land's End. Oh, let's start at Land's End. Why not? So it's arbitrarily as to which one you start at, and we've chosen Land's End. Okay, so L is part of our tree, and I'm just going to highlight down here where I'm starting. So, what's the closest node to my tree that's not already a part of my tree?
TR.
Yeah, TR. There's only one, so I've got to choose that arc there. That has to be part of it. So I'm just making a list now. So L to TR, and I'm making a note of how long that is. That's 37. Okay. And the next one, this one I've got a choice. So I either choose to go from Truro to Bodmin or from Truro to Plymouth, and I would choose Truro to Bodmin because that's the closest. So therefore, that's my next arc that I choose. Truro to Bodmin, and that's a length of 26. Now, common mistake here, well, it wouldn't actually affect this part of the question, but you don't just look at the branches of the node you've just included. You've got to look at your whole tree. So I have to take into consideration Truro to Plymouth as well, because if both of these were greater than 52, then it would be the 52 I'd be choosing, because that would be the closest node to my tree via that arc. Okay, so to make sure you continually look at the whole tree, not just the nodes you've just gone to. In this case, it doesn't actually matter because I'm going to be choosing this arc here. Okay, Bodmin to Plymouth. Make a note, go on there, Bodmin to Plymouth. Distance of 31. And now I really do have a choice. I can either go to Oakhampton or to Torbay. Okay, they're both shorter than that one, and I can't choose that because both Truro and Plymouth are part of my tree, so I can't choose that one at all. So, has anyone got a preference? Up. Let's go to Oakhampton. Plymouth to Oakhampton, distance of 31. Again, looking at my whole tree, I've got a choice of 31, 46, or 23. Can't choose that one, can't choose that one, because they would create cycles. So the shortest of those three, therefore, is 23. And actually, this tree is really uninteresting, isn't it? It's just a long line. Oakhampton to Exeter is 23. And then finally, Exeter to Torbay is 22. And if you sum those up, it should come to the same distance that we had yesterday when we did Kruskal's. Yeah.
It's the same tree yesterday, with the exception of the you can choose which 31 to go on.
Is it exactly the same tree, is it? Brilliant, yeah. I mean, rather than going up, we could have gone to Torbay, at which point the tree would have gone around here instead. It's a different solution, but it is still optimal because they are both total length of 170, so it doesn't actually matter. Okay, but 170 is the optimal solution. course, this is a very uninteresting tree because it is just one long line, whereas actually trees can be fairly more sporadic in the general case. Okay, are we happy with that?